Dear colleague, good evening. Professor Alauddin Kuka will present an oral communication at this conference. Professor, it's for you.
Okay, thank you. So, hello everybody. Good afternoon, distinguished researcher, professor, doctors, PhD students, ladies and gentlemen. It's my great pleasure to be with you with this conference. First of all, I would like to thank the chairman, Professor Kermouche, for the organization of this conference. ACMS, International Conference on Materials Science. So my presentation is entitled Surface Treatment of Titanium Alloy, Enhancing Corrosion Resistance and Biocompatibility and for Biomedical Applications. So let me present myself. I'm Professor Aladdin Kaouka at High Normal School of Lagouat, École Normale Supérieure Lagouat from Algeria. I am doing research about surface treatment. So why I'm interested about this topic? First of all, we will see in these outlines why we are interested about titanium alloy and then surface treatment. After that, we have the powder metallurgy and some characterization with optical microscopy and CM, scanning electron microscopy, and the micro hardness, and we determine with toughness and corrosion and wear resistance of titanium alloy. After that, we have topological characterization and corrosion resistance, and we finish this presentation with conclusion and perspective. So maybe you are asking why we are interested about titanium. So titanium, as you know, it's promise metal for its good characterization. Titanium, it can be between iron and aluminum. You can choose titanium for the low density, high specific strength, excellent corrosion, very good fatigue behavior, and most also special excellent biocompatibility. So for this, why titanium alloys are widely used for dental implantation, for dental implantation, and also aeronautic and aerospatial. There is two big area to apply this metal, and there are many. This is the structure of titanium alloy after annealing at 700 treatment. This is not my work. This is the reference. You can check it or you can follow it. And for the publication recently, there are many publications about titanium alloy. As you can see here, with publish and perish software, we have many citations on many papers for titanium alloy, and this is the increasing number of publication of titanium between 2000 and 2024. Indexed in Scopus and in Google Scholar, and also Web of Science. There is a high increase of publication about this. The hot topic of trend, especially in nanostructure, plasma bust surface, and bio and antibacterial surface. So we are interested to improve the surface of titanium alloy. And you can see here, you can click only in Science Direct or MDF to check other publications. So our work focus on surface treatment with boriding. Why we are interested about boriding? Because boriding, as you know, normally it's very important surface treatment, thermochemical surface treatment, which the bond diffuse into the surface of treatment of material. This material can be iron, cast iron, steel. We have many publication about this material. However, we focus on titanium alloy. That's a new treatment. So due to the wear beneficial provide of boride layers that can give give us the boriding treatment. And due its temperature and wear resistance, boriding is also a good choice for certain tooling application. For example, for the whale, this whale for tobacco processing or anything, tungsten and pipe fittings and gearings and many others application. And also we can achieve the process of titanium sorry, boriding treatment with this compound, this composition, 90% of borax and the boron carbide and silicon carbide, or also another compound is commercial, known by this name, Icabor 2. So Icabor 2 is what? 5% of the carbon and 90% of silicon carbide, as you can see. This is schematic view of illustration of boriding process. This is our samples, and this is electrical furnace. We put this in the crucible and in the furnace, and after the treatment we have some characterization of boride layers, microstructure and mechanical, optical microscopy,
Okay.
CM scanning electron microscopy, and X-ray diffraction, and also EDS analysis. As mechanical characterization, we have the micro hardness and the fracture toughness. So this is with CM.
Sorry.
Sorry.
No, no, no. Good.
Okay, so
Sorry.
this is this figure of the diffusion of the bright layers that we have in different temperature. So this is the bright layers that we have. For non-treatment titanium alloy, as you know, we have only alpha and beta phases. After the treatment, we found in titanium alloy, the composition, we have the molybdenum and the boron. This is the boride layers, dental like this stress of what? Of boride layers formed on the surface of titanium alloy. And after that, we have TeB2 and Te titanium alloy, alpha titanium. So we have boride of this treatment. We compare our results, but compare with old results that we have, previous results that we have published before. We used steel, carbon steel, and stainless steel for boride layers. This is intermediate. This is the steel. This is zone translation, and this is the boride layers that we have. And down here is the substrate. So this is iron boride, and this is iron 2 boride, and this is the substrate. This treatment for carbon steel at 900 uh, at 900 degrees Celsius. And for silicon carbide, so we have B phase, double phase, iron 2 boride and iron boride. If you use only borax and silicon carbide, we have monophase. We have only one phase, iron 2 boride. We don't have iron boride. So this is the X-ray diffraction peak to confirm that we have the phases of iron boride and iron 2 borides at different temperature and different chemical composition. After that, we try to measure the thickness of boride treatment. This is traditional method. So we use a new method using image launcher software, which is free. You can download it by internet. So we found that the average is about 60 micrometer, and this is old results that we have published before, and about 60 until 280 micrometer, and it's very important thickness. So after that, we have the surface profilometry. In the left side, we didn't achieve the treatment. However, for the right side, we achieved the surface thermochemical surface treatment, and we have this profilometry of surface to found with the length of boride layers. And we also measure the thickness and micro hardness of boride layers with this relation, and we found that is about 2 between 2.82 and 3.75. So for friction curve, also sorry, for the time, this is the first phase, second phase, and the third phase for the friction phase. And this is our results about iron boride, iron to boride, the micro hardness. And then this is the boride layers when we attack with HCl for to study the corrosion. So we observed the surface boron treated after attacking during about 4 days in sulfuric acid. So this is the corrosion produced. So there is no affected by corrosion environment. And also this is we have studied, it's a long study, so I try to summarize for electrochemical corrosion, sulfurous acid, and NaOH, KOH, and HCl, the results that we have. So I will conclude that the new technology was used to evaluate the boride layer thickness for titanium alloy successfully achieved or realized. It was show the sawtooth structure with the enter about 200 micrometer, and the micro hardness was about 1170 and 1870 HV hardness vehicles, and the fracture toughness it range between 3.9 and 4 3 and 4.48. And the activation energy, sorry, I didn't give details about this. Activation energy is about 2 260 kilojoule per mole over mole. So for abrasive wear resistance of bright layers was approximately about 4 to 5 times greater in comparison with untreated one. So the results under dry conditions so that the bride revealed a high wear resistance than bride steel, and the coefficient of friction value were low than untreated. So it's about 0.16. So finally, we can say that we achieved and we titanium alloy treated were processed by powder metallurgy and using a blended elemental. Their microstructure are changed into titanium, and effect of such changed or their mechanical properties. We improve some mechanical characterization and as the micro hardness, and also the chemical characterization and property such as corrosion resistance. So that's all, and thank you for your attention. And if you have any question, you can ask me, and if you want to collaborate, you can contact me with my email below. Thank you, Chairman Professor Kermoush Ahmed.
Thank you very much, Professor Alauddin Kaouka. We have time for 2 or 3 questions. Any questions, please? Dr. Majda Ajili from Tunisia, welcome.
Yes, please ask.
No questions? I think I have a question, Professor Alauddin.
Yeah, please.
It's a general question.
Yeah.
This topic is classified as functional materials science. Okay. My my question is, how do these anodic oxidation you were treating, how do it influence the corrosion resistance
The influence of what?
How do the anodic oxidation, the plasma electronic oxidation, etc., influence the corrosion resistance
Okay.
and the biocompatibility of titanium alloy for orthopedic biomedical applications? Okay.
Yeah. Okay. Thank you for your question. So the influence of oxidation here in our case is boride titanium layers on corrosion resistance. So it depends strongly on the nature and thickness of boride layers that we have, and also the stability of oxide formed. So due to the boriding, we have TEB and TEB2 as formed on titanium surface. So that's it. Multi-layer couche, multi-layer, so couche
Yes.
en français, has excellent
Yes.
corrosion resistance and also high hardness and wear resistance. Has an excellent corrosion resistance. So this is controlled the boriding applied on titanium alloy for oxidation treatment is considered an effective surface engineering because it's combined the high hardness of titanium boride with the excellent passivation ability of TeO2. Okay, so leading to this, so we have this layer, this couche.
Okay. Very good talk, Professor Alauddin Kaouka. We thank you very much.
Okay, thank you. Thank you very much. I
Okay.
will thank you for this opportunity to participate, Professor. And I
Yes.
hope
You're
to
welcome.
collaborate with you next time.
You're welcome.
Thank you.
You're welcome.
Thank you very much.
Thank you. دكتور أحلام